Quick review of the Pythagorean theorem. It works for right triangles. Here's the formula. C is the hypotenuse. The hypotenuse is the longest side, which is the side opposite the 90-degree angle. What you can do with the Pythagorean theorem is if you have A and B, you can figure out how long the side C is, and you go through this formula here. Okay, that's the Pythagorean theorem. We can use the Pythagorean theorem to figure out the distance between 2 points on a coordinate plane. To do that, we just notice that the distance from here to here is just x2 minus x1. And the distance from here to here is just y2 minus y1. And this here is a right triangle, which makes this a hypotenuse of a right triangle. And so now we just take these, plug them into this equation using the same Pythagorean theorem, and we can figure out how big PQ is. Here's the app. We've got 40 faces here. We actually have 10 poses for each one of these faces. To see the 10 poses, I click on a face, and I get the 10 poses. If I go back and click on a face, I get the 10 poses that go with that face. Try it again. I'll click on this face, and I get the 10 poses. Now, if I click on one of these poses, what I'll get is altogether we've got 40 times 10. We've got 400 images, or 400 faces. And what will happen is the computer will search through those 400 images and find the 10 closest, what it considers to be the closest matches to the face that I click on. So I'm going to click on this face, and it picks 1. That's the closest. It's not the face, it's the closest. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now if you notice, some of the faces don't belong to that original person. And you can tell which ones don't belong. Well, you can tell just by looking because it's not the same face. But the ones that are circled in red are the ones that are the wrong face. The green are the good faces. Now we're going to go to a screen that allows us to compare the pictures. So it's going to allow us to compare, for example, if I click on this one, it's going to allow us to compare this picture to the picture I clicked on the previous picture, on the previous screen. And it's also going to show us what the computer sees when it sees one of these images. So I'm going to click on this picture. Now this is how the computer sees the pictures. Now we want to bring it back to what we look at just so it's clearer. Okay, so over here, this is the original picture I clicked on. This is the one I just clicked on the previous screen. Now we'll go back to the computer representation. Okay, so the computer sees this thing in very low resolution. It's got, these are the pixels. It's got 23 pixels in this direction and 28 pixels in this direction. So it's low resolution. Each pixel represents a coordinate. So back when we were looking at the distance between 2 points formula, we had 2 coordinates. We had an x and a y coordinate. To find the distance between 2 points, we would get the difference between the x coordinates, and then we would square that. The difference between the y coordinates, we would square that. Then we would add those together and take the square root, and that's how we get the distance between those 2 points. Well, this is exactly the same thing, except the difference is we have 1 all the way over to 644. So 644 is this one over here. 1 is over here, and it just kind of goes like this. Goes here, and then it starts over again here. So we got 1 through 28. Then we've got 29. Then we've got 56, and so forth. So there's 28 pixels in this row, this column, 28 pixels in this column, and so forth. And it just stacks these on top of each other. So the first one is 1. The last one is 644. 644 turns out to be 23 times 28. So we've got this coordinate. No, we got this point. You can think of it as a point with 644 coordinates instead of a point with 2 coordinates. But from that point on, everything's exactly the same. We get the difference between each pixel, or each coordinate. So the difference between 45, okay, let's take a look, pull up the calculator. So you've got put a parenthesis here, you get 45 minus 52 squared, that equals 49, which we've got up there. Okay, so we've got the difference between this first coordinate, the corresponding, got the coordinate for the two different faces, get the difference, square it, and that's that number up there. Now let's go to another one. Okay, so I'm going to go to this one, which is going to be the 28th coordinate. Okay, so here we are at number 28. Okay, let me make, did I click on that? What happened here? Okay, so that's 28. It's coordinate number 28. Let's look at, what do we get when we get the difference here? We're going to get 34 minus 44. We square that, and that's equal to 100, which is what we've got there. We can do that with each one of these. Now pixels, the way they work is the lower the value, the darker it is. So like, let's look at this one. Okay, that's very dark. It's got a value of 9. This one up here is a little bit brighter, and it's 51. So this is the color of this pixel. That's the numeric value that the computer uses to determine which color it is. This goes with this one, and that number is the value the computer uses to figure out what color the pixel is. Okay, so what we actually are using for face recognition, we're actually using the difference, the distance between 2 points formula, which is a version of the Pythagorean theorem. So this is an exercise in an application of the Pythagorean theorem. Now, go back to the first screen where we have our 40 faces. Now what will happen, this is only a prototype. Now in the real version of the program, the program will enable the students to take pictures. So you could get, if you have a classroom of 30 students, you'd have 10 pictures for each student. You'd be able to upload them into the program and then work with the kids in the classroom's faces. So that should be kind of cool because the kids could, they could make faces when they're taking pictures to see what happens, see if they can make themselves not look like themselves, make themselves look like their friends or whatever. They could do all of this kind of playing around while learning an application of the Pythagorean theorem and maybe even finally remembering it and actually liking it.